let's say we want to find the sine and cosine of a 30-degree angle. I will draw the triangle here again. Then the theta is now 30 degrees. So this, we know that this is 1. What if we now build another triangle with 30 degrees here? It's also 30. So this is 60, but this triangle, this is length is 1, this is also 1. Therefore, this length must also be 1, so that the sine will be half. So sine of 30 is equal to half. And we can also easily work out the cosine by using Pythagoras. So we can say that the hypotenuse squared minus sine squared is equal to cosine squared. So that means that cosine theta squared will be equal to 1 squared, the hypotenuse squared, minus sine squared, which is 1 over 2 squared, which becomes 1 over 4, which gives us, this becomes 4 over 4 minus 1, 3 over 4. So the cosine of the angle is square root of 3 over 2. So now we know the sine of 30 of a 30-degree angle and the cosine of a 30-degree angle. All right. Let's say now we have an angle of 45 degrees. Now this will be theta 45 degrees. That means that this angle will also be 45. This is 90. So the sine and cosine must be the same. Sorry, the scale is not really correct. So that means we know that this is 1 again, the hypotenuse. I'm simply drawing the triangles out of the circle, but the hypotenuse is always 1. So that means that sine theta squared plus cosine theta squared is equal to 1 squared, which is 1. This also gives us a very important and useful identity. So this identity always works for any angle because the hypotenuse is always 1. So you can see that the unit circle allowed us to get this identity. But let's see what happens for an angle of 45 degrees. Since sine and cosine are the same, we can say that 2 times sine theta squared is equal to 1. So that sine theta will be equal to square root 1 of 1 over 2. Alright, so which is 1 over square root of 2. Okay, if you want, you can rationalize the denominator. We can do that. Let's say we multiply by square root of 2 both the numerator and denominator. We get square root of 2 over square root of 2 times square root of 2, which gives us square root of 2 over 2. Okay, so this is sine of 45 degrees. The angle is 45 degrees here. Theta is 45 degrees. And the cosine will be the same because of what I've mentioned to you earlier. So cos 45 degrees is also equal to square root of 2 over 2. Alright. Let's take another interesting and useful triangle. We take a triangle where we took a 30 degrees, 45. Let's take a 60 degree triangle. Let's now take a 60 degree triangle. So a triangle where the angle here now 60 degrees. Theta will be 60. So that means always remember that this length is 1. This angle is 90. Therefore, this angle here is 30. Remember that the sum of all interior angles of any triangle is 180. So we have 60 plus 90. We are left with 30 to get 180. So this is essentially the same as the 30 degree triangle I've drawn above. So we can quickly see that if this is 1, this will be, so the cosine will be half. So cosine of 60 will be 1 over 2. And the sine will be sine 60 will be 1 squared minus 1 over 2 squared. You have to square root it, so that becomes 1 minus 1 over 4, which is 3, over 4. You have to take the square root. That becomes square root of 3 over 2. Okay, so as you can see, you can get all this information, something you can get easily out of the unit circle. So that's why the unit circle is important.